This is again a very beautifully framed question asked in GATE 2024 examination. A 4-bit priority encoder has inputs D3, D2, D1 and D0 in descending order of priority. That means D3 has the highest priority compared to D2 and D2 has the highest priority compared to D1 and D0 has the lowest priority. And we know that priority encoder, how it works, how it works. If more than one input lines are at logic 1, then the output is produced according to that input whose priority is the highest. Okay, that is the working of the priority encoder. Okay, so the 2-bit output AB is generated as, if D3 is 1, how encoder works? In case of encoder, in case of normal encoder, you know that only one of the input line is 1, and while in case of priority encoder, more than one input lines can be 1. Okay, so when we decide the priority, if more than one input lines are at logic 1, then we decide the priority. If D3 has the highest, if let us say at the input lines D3 and D2 both are 1 1, who is having the highest priority? D3. Then output will be produced according to D3. And what is the output? The 2-bit output AB is generated as 0 0 0 1 1 0 and 1 1 corresponding to inputs D3, D2, D1 and D0. Means if your D3 bit is high, means if there is 1 at D3 bit, then it will generate output 0 0. If at D2 there is 1, then it will generate output 0 1. If at D1 there is input 1, then it generate output 1 0. And if D0 there is 1, and then it generate output 1 1. So this question is very important question. Why? Because they have changed the order. Normally when the input line at D3 is 1, then normally output is 1 1. In case of normal encoder, what we take? 1 1. If D2 is at logic 1, only D2 is at logic 1, we'll take 1 0. If at D1 only there is 1, then we take as 0 1. And if D0 is only 1, then we take at 0 0. And in case of priority encoder, we look at the priority of the bit if more than one input is at logic 1. So here they have changed the order. Corresponding to D3 there is 0 0, corresponding to D2 there is 0 1, corresponding to D1 there is 1 0, and corresponding to D0 there is 1 1. They have reversed the order. Okay, now let us form the truth table. The Boolean expression of the output bit B is asked. Let us form the truth table. So input line is D3, D2, D1 and D0. So for 4 input lines there will be what? 16 combinations: 0 0 0 0, 0 0 0 1, 0 0 1 0. Let us take it, because we have to write all the input combinations. So take it as 0 0 1 1 0. 1 1 1 1 1 1 1 0 1 1 1 1 0 to 6 15. There are 16 input combination. And you know that in case of encoder, all the input lines should be 0 is not possible. All the lines are at logic 0 is not possible, because in case of encoder, at least one input line should always be, at least one input line will always be at logic 1, because the input of encoder is nothing, it came from the output of a decoder. And decoder, in case of decoder, at least one output will always be at logic 1. So in case of encoder, all the input lines are at logic 0 is not possible. This combination will not happen at all on the input side of the encoder. And the input combination which cannot happen, or which cannot be there at the input side, the output corresponding to that input is taken as don't care. So all the input lines are at 0 0 in case of encoder is not possible. At least one of the input lines should always be at logic 1. More than one input can be 1. It is possible in case of priority encoder. Okay. So all the input lines are 0 0 is not possible at the input side. This combination will not happen at the input side of the priority encoder. So output corresponding to that input combination which is not possible is always taken as don't care. So 0 0 0 1 here D naught is 1 and only D naught is 1. So only one bit is 1. So it is having the highest priority obviously, and corresponding to D naught, if D naught is 1, output generated is 1 1. Order is reversed, not 0 0 1 1. Here only D1 is 1, and if single bit is only 1, then it is having the highest priority, and corresponding to D1 your output is 1 0. Reverse order 1 1 1 0 0 1 and 0 0. Okay. Here two ones are there. Here two ones are there. D1 is also 1, D0 is also 1. Which is having highest priority? D1 is having the highest priority among D1 and D0. So corresponding to D1, what will be the output? 1 0. Here only single one is there, and that is D2, and corresponding to D2, there is output is 0 1. If only D2 is 1, it is having the highest priority. Here D2 and D0 both are 1. So obviously D2 is having the highest priority among D2 and D0, and corresponding to D2 the output will be 0 1. Here D2 and D1 are 1 1. So among D2 and D1, D2 is having highest priority, so corresponding to D2 output will be 0 1. Here D2, D1, D0 both 3 are 1. 3 are 1, but the D2 is having highest priority, so output will be 0 1. Here only D3 is 1, D3 is 1, corresponding to this output will be 0. Now for all the input combination from this onwards, output is going to be 0 0. Why, sir? Because D3 is always going to be 1 from 8 to 15, and if D3 is 1, it is having the highest priority. Other bits are at logic 1 or not, it doesn't matter. If D3 is 1, D3 is always having the highest priority. Okay, and corresponding to, if D3 is 1, output is always 0 0. So corresponding to term 8 to 15, output is going to be 0 0 always, 0 0 always. Okay, now write down the Boolean expression for B. What will be the Boolean expression? Okay, in form of SOP. In SOP expression, we take those terms for which output is, those input terms for which output is 1. So corresponding to combination 0 0, output is don't care. Corresponding to term 1 is 1. Corresponding to term 1 it is 1. Corresponding to term 2 it is 0. Corresponding to term 3 it is 0. Corresponding to term 4, 5, 6, 7. Corresponding to term 4, 5, 6, 7 it is 1. And then again for 8 to 15 it is 0, plus output B is don't care for combination 0. Now solve the K map and get the answer. Solve the K map and get the answer. Here D3 bar, D2 bar, this is A, B, C, D. D3 bar, D2 bar, D3 bar, D2, D3, D2, D3, D2 bar. Here D1 bar, D0 bar, D1 bar, D0, not, and D1, D0 bar. Okay, so term 0 1 corresponding to 1, output is 1. 2 3 is missing. Term 4, term 5, term 6, term 7, and for corresponding term 0 there is don't care condition, and for other combination output is 0 obviously. 8 to 15, 8 9 10 11 12 13 14 15 obviously. So let us form the best possible combination. Here you will be able to form a one quad here, and corresponding to this one you can form a quad here by using don't care. So there are two quads. The value of this quad will be what? D3 bar, D2 bar, D3 bar, D2, and corresponding to this quad, what will be the value? From here D3 bar will be retained, and from here D1 bar will be retained. So the value of this quad is D3 bar and D1 bar. Answer is B is nothing but D3 bar, D1 bar, D1 bar plus D3 bar and D2. So D3 bar D2, D3 bar D1 bar. This is the answer, no? D3 bar D1 bar and D3 bar D2. So obviously option B is the correct option. So very beautifully framed question, because in hurry you can solve this incorrectly knowing everything. Why? Because in general, corresponding to D3 bit, if at D3 bit there is 1, output is in general 1 1. Corresponding to D3 output is 1 0. Corresponding to D1 output is 0 1. Corresponding to D0 output is 0 0. Okay, but here they have reversed the order, and that's why this question is tricky. If you won't read the question carefully, you will end up finding the wrong solution. Okay, so now let us discuss the next question.